So recording has started. So our devotional for today is Luke 12:48. Everyone to whom much was given, of him much will be required, and from him to whom they entrusted much, they will demand the more. So anyone have any comments about this devotion or this verse? So certainly all of you have been giving some quite a few gifts, and you have been given quite a bit, and of you a lot will be required. So something to keep in mind, that these gifts that you have been given are not just solely for you to be blessed, but also that you are supposed to do something great for his kingdom. So that's something to keep in mind, that you have been entrusted with a lot, and so a lot of will be expected from you. All right. So the administrative slide. So there's acceptance of the syllabus is due by midnight tonight. The other thing is there's an assignment for an operating system topic where you're going to give a brief discussion of some operating system area or a particular operating system that catches your interest, and you will present a devotion and a presentation on that topic. We will have teams of 2 or possibly 3 if they don't even out correctly, but so that you can work with someone else on the project. So anyway, take a look at that assignment and think about what you might want to give a presentation on. We will have a quiz on Chapter 1 on Friday, January 29th is the plan. And today we're going to start with slide 16 of where we left off. But quick comment is I just want to make it clear that I'm not Dr. Lim. I do not have a PhD, and actually am not pursuing a PhD. So, you know, either Mr. Lim or Professor Lim is fine. So anyway, just want to put that out there. My background is I've been in industry for 35 years. 25 years as a computer scientist at Lawrence Livermore National Lab doing various types of research, software for research. So lots of different areas there. And then the last 10 years, I was in the medical device industry writing software for a medical device for ophthalmology and optometry. So anyway, that's just sort of a background. It's not trying to demonstrate my accolades or my accomplishments, but just so that you know where I'm coming from and what my biases and my filter is in presenting the material. So just sort of a understanding of where my background comes from in regard to what my lectures look like. So I am going to bring up the slide, the presentation, and off we go. Let's go to slide 16. So this is sort of a review of what we ended with last lecture, last week actually, and there was a question about what it means by increasingly CPU support multi-mode operations, and I referenced the text and said you could look at that in more details, that there's probably a more detailed explanation, but I gave my definition of what I thought that meant, and I did go back to the text and it was exactly what I said. I don't know if it was clear or not, but it's basically that the CPUs support this concept of user mode and kernel mode, and will actually limit execution of specific commands to only the kernel. And so when you are not in kernel mode, those commands will not be allowed to be executed. And then other areas of the operating system of the system will also not be allowed to be accessed unless you are in kernel mode. And that is such a common method used in operating systems that is supported directly by features of the CPU. So,
hey, Professor Lim, I hate to interrupt, but have you turned on the stream for the slides? Because I don't think any of us can see them.
Oh, okay, thank you. Okay, can you see it now?
Yes.
Great. Thank you for doing that. Definitely online, I'm doing a lot more multitasking, so I appreciate, and actually even in class, if you comment that I'm going too fast or something wasn't clear, all those kinds of comments definitely make my job easier. So thank you, Gabriel. Do you go by Gabe or Gabriel?
I like Gabe best.
Okay, thanks, Gabe. So anyway, any questions about what I talked about here? So one of the things to keep in mind is what is the purpose of an operating system? And we kind of talked about on a previous slide or in my previous lecture about some of the features of an operating system and what kinds of support it provides. But given the intro that we've had to operating systems so far, what would you say would be the main objective of an operating system? Anyone would hazard a guess or have an idea of what that might be? So how about you, Seth? Do you have any idea of what you would, if someone were to ask you what's the purpose of an operating system, what would you say that is?
I would say that the purpose of an operating system is to manage the hardware so that users can to provide resource allocation and to manage hardware for some other problem to be solved, either for users being able to access it or for to prioritize just being able to run.
Good, very accurate, and I appreciate that it shows that you gathered the information that was in my previous lectures. So that's good. So your textbook, in its definition of an operating system, I believe, says it creates an environment within which other programs can do useful work. But like Seth said, ultimately, you're providing control and support of your hardware for the user. But again, your text refers to it as purpose of an operating system is it creates an environment within which other programs can do useful work. And so that's a good definition of an operating system too. Again, I think that is probably universally accepted. I know that the functionality and what exactly the definition of an operating system, like we said, can have different interpretations of exactly what is part of the system and what it's not, and what it consists of. But that is a good definition, is it creates an environment within which other programs can do useful work. So anyway, keep that in mind. So the next thing is process management. So the main unit of work in a system, an operating system, is a process. It's a process is a program that's currently in execution. It's actually being actively executed by the CPU. And it is the main unit of work for the system. So this is an important concept to understand, is that the main unit of work for the operating system is a process. So keep that in mind. Process needs resources to accomplish its task. You can see the resources that are listed there as examples on the slide. Process termination requires reclaiming of any reusable resources. So as a process uses resources like memory or whatever, when the process terminates, those all have to be returned. Otherwise, eventually you just start completely running out of resources, obviously. A single-threaded process has one program counter, specifies the location of the next execution, and it also has what we'll learn later is a context, which is all the information that's entailed with that particular process. Multi-thread process has one program counter per thread. We will learn actually that in the Linux operating system, that threads and processes are synonymous, that there is only one thread per process in the Linux/Unix operating system, which is actually kind of surprising to me. It's so surprising, I actually mentioned that to Dr. Gowing. He says, no, that can't be right. And he actually researched it and tried it on a system, tested it, and he said, oh, actually it is right. So it is actually not intuitive, but you'll find that Linux actually has that thread and process to be one and the same. And typically, a system has many processes, and it quickly switches back and forth between the different processes in a multiplexed way. Any questions about this? Various things that needed to be done for process management can be seen in this slide. You need to be able to create and delete both user and system processes. We need to be able to suspend and resume the processes, and that is necessary for the multiplexing, the sharing of the CPU and various resources. You need to provide mechanisms for process synchronization, and we'll go into that in more detail. But typically, you will need to synchronize and coordinate different processes in order to allow them to work together. And then there's typically a method for providing process communication. In other words, processes can share information, and how do they communicate amongst each other is usually a mechanism that is important. And you'll see in real-time operating systems that frequently done. And so most of your embedded programs are generally done on specific real-time operating systems with those kinds of goals in mind, and allowing you to control and band how long a process can take at the maximum. You want to be able to guarantee that the task in a real-time or embedded system can finish in the allotted time. And then the operating system may provide mechanisms for deadlock. And that is a synchronization issue, that if you have multiple processes that are syncing, you can actually get into what's called a deadly embrace, which is a deadlock situation where all the processes that are synchronizing together get locked in some kind of stalemate position and cause the system to hang, or those processes to hang. Memory management is another function that's provided by the operating system. It's basically allocates the memory so that multiple processes can use all or part of the memory, and it actually does the allocating of memory and who gets to use what part of the memory. And it needs to be done in an optimized way for both the memory and all the other resources, in particular the CPU. And then you can see here that there are other memory management activities, keeping track of who's using what memory and where it's located and where its information is, deciding which processes can move information into and out of that particular memory, and then allocating and deallocating and managing the memory space in general are the activities done by the operating system. Storage management is very much akin to memory management. It's just generally disk systems and file systems that you're all, I'm sure, pretty familiar with. So this is generally persistent data that's stored in a persistent file, as opposed to memory, which is volatile. When the power is turned off, in general, the memory information is lost. There are exceptions to that. There is non-volatile memory involved in systems, but in general, when we're talking about storage management, we're talking about non-volatile storage of data. So I'll give you a few seconds to look at that. I think you're probably all aware of working with files and things like that. Let me know if you have any questions about what's about there. Pretty straightforward and something that you're probably quite familiar with. Okay, and the last topic is protection and security. That's becoming a larger and larger, or more and more important, and a larger task as you do your application programming or whatever type of programming, is to keep security and protection in mind when you're writing your software. And the operating system will provide support towards those roles. We won't go too much into this area. We'll look at it at a fairly superficial level in terms of what kinds of protection and security services and operating systems provide. But I'm sure all of you, or a lot of you, will get a chance to participate in Dr. Gowing's class, in which case you will get a great deal of detail, much greater detail on what's involved in security. So it's basically trying to protect against malicious access to information and system and resources, or inadvertent access to resources and information that you don't want them to access. So that completes chapter 1. So I think you should be well versed in chapter 1 in preparation for the quiz on Friday. So again, I'm hoping you should all do well. I did have a student that at first was taken aback by that we would have so many quizzes, and that she thought it would be quite difficult. And then after a while, she realized, you know, it's not really that bad. If you pay attention in class, you should be able to do fairly well on the quizzes, and I hope that's the case for you guys.
Excuse me, Professor.
Yes.
Are these slides on Canvas? I don't know if you said this or not.
Yes. If you go into the module section on Canvas, these slides are on there. And please let me know if there is a missing slide or you're not able to access it. Again, I have the ability to, there's a mode that says see the student view, but as I have been warned by other faculty members, that student view is not necessarily accurate. and I may think you are able to see it and you're not. If you go to the modules section of the Canvas site, these slides are available.
Alrighty, thank you.
Yes. All right, so can you see that slide? My title slide, Linux commands?
Yes, yes, we can.
Thanks, Gabe. Great. So here's a little Linux command cheat sheet, cross-reference. It's basically got a quick listing of a small subset of the commands that you have in Unix/Linux. And since you will have some programming assignments in Linux, I have a quick review to get you started on some of the common commands that you may encounter. Certainly, this is not all inclusive, and you will need to learn some other ones. And in particular, you will probably need to download some code onto your Linux operating system, some system components, shall we say. And I'm not sure I've actually covered that in this, is included on this little sheet here. And it will actually differ depending on what variation of Linux you're using. So anyway, here's a slide of Linux commands, and actually I'm going to go to a different version of this. Missing my notes. I don't know where they went. All right. I will do it without notes. Okay, so here are the various Linux commands. The ls command is for directory listing. So those of you that come from the DOS world, know this is dir, which is a directory listing. In Linux, that equivalent is ls. Now, as you can see here, you can actually add options to a command or qualifiers to your command. And so we can see here another one is ls minus al. So the -al are the options that you've done it. And the A actually says show me all the files, which includes the hidden files. And then long says show it in a long format, which actually shows things like file permissions, who owns the right to read, write, or execute that file, and the file size and things like that. Whereas if you just do ls, it will be just the names of the files, and so-called hidden files will not appear in the directory listings. So let's see. Trying to without my notes, I'm trying to figure out exactly what I had deemed as important. Pause. Okay. So all right. Okay, now I've got some notes. So change directory is changing to a directory cddr. Those of you who have done the DOS command prompt from Windows or even DOS itself will recognize that. And CD by itself is change directory to the home directory. I believe in DOS, if you do CD by itself, it actually show you the current directory, if I remember right. I may be mistaken, but to see the current directory that you're working in is PWD, which stands for print working directory, is show current directory. So one of the things you can note is that all the commands in Linux are very short and terse and abbreviated. So for instance, you saw that ls is a directory listing instead of dir. So typically commands are usually only a couple of letters, except for the few exceptions. We can see here, make directory is the create a directory. And that's the same as DOS. And then removing a directory in your DOS is the DOS equivalent of delete, the delete command in DOS. We can see here that there's deleting a directory is delete -R is how you would actually delete a directory. If you do just a remove and give it a directory name, it will actually say, this is a directory, you're not allowed to delete it. Use in a might if it's has useful feedback, it will actually say use the -R option to remove this directory. And then remove -RF, it says it's to force removal of the directory, and that can be a dangerous command because if you use star, it can delete a lot of files. So that's a command that you need to be very careful of and understand exactly what you're doing with your remove commands, with the command options. One thing that you can generally do is use a -H or a -? Or a -- help qualifier to get useful information about the command. It'll give you information about the command line options, the dash options. Another place you can do that is the man command. The man command is very useful. You type man and the name of a command like cd or something like that, and it will actually present the manual for that command. So can you see my cursor highlighting the man command on the sheet?
Yes.
Okay, good. So right here is the manual command. That is an important command to know because it will help you when you're trying to figure out exactly how to use a command. And in particular, I find useful, it will generally show examples of using the command, and you can try to find an example that matches what you're actually trying to accomplish. So the man with the name of the command shows the manual. So man, and then here if you do, let's say cat, man cat will actually show the manual for the cat command. So that's important. We have symbolic links, which I probably won't go into too much detail, but it is a mechanism where you can create a link, a virtual link to a file, so that when you look at a directory listing, what you'll see is what looks like a file name, but actually it is a symbolic link. It's a link to another file. It's like a shortcut in Windows, if you may. Something like that, but probably I would say a lot more powerful than actually a shortcut in Windows. Touch. The touch command is useful. It doesn't sound like it would be useful, but you do touch and the name of a file. If the file doesn't exist, it actually will create an empty version, basically a file of size 0 with that file name. And if you do touch and the file name of a file that actually currently exists, it will change the date and time to the current date and time. So that is actually a very useful command in scripts and things like that for both creating a file. Let's say you're going to use a file in a directory to indicate that something has completed. And you see this when you download files, you'll see that you'll actually see some type of mystery file in their system that says it's currently downloading. You can't actually open the file, even in Windows. I mean, this is typically you see this in Windows, but it's a marker file that says something is happening. And so this is how you would actually create that in a script. So one thing that's useful about these Linux commands is they can be chained together in a script, or in the DOS world, it's a command file, or I mean a window in Windows or DOS. It's a batch file or a command file. This is the same thing in Linux, and the Linux shells actually are a very powerful programming language in itself, and you could do quite a few things scripting all these commands into a program, and that is actually where a lot of the power comes into using Linux, is tying together some of these Linux commands into a script and actually creating quite useful programs with them. So cat, again, being the very terse language that, or command line that it is, stands for concatenate and type. And basically what it is it just lists out the contents of a file. And here we can see the command cat with a greater than symbol. What that says is we're going to cat out a particular file, and it places the output of it into a file on this side of the greater than symbol. If you don't use this greater than symbol and basically send the information to an output file location, it will by default go to the screen. So if you just do cat and a name of a file, it will actually type out the contents of a file. And I believe in DOS, that is the type command. More shows the contents of a file in a way that will actually stop and pause for you to press a key before it goes on, so you can see a screen at a time instead of just having it all scroll past if there's more to the file than will fit on one screen. There's also a version called less, which is a streamlined version of more. But one of the things about more that is useful is that you can actually scroll up and down and navigate through the file through the more command. And why this is useful as opposed to just using an editor, sometimes you may have a file that is particularly long and loading it all into memory would be prohibitive. You can use more or less to access the contents of the file in a more efficient way, looking at it a piece at a time for a very large file. Head allows you to look at the beginning of a file. Without a command line option, it by default shows the first 10 lines of the file. And then tail is the opposite. It shows you the last 10 lines of a file. And you may be wondering, why would these be useful commands? And you actually find that a lot of people will add Linux command processing software to Windows systems just to use the tail function. And where this can typically be used is the tail -F option. You do tail -F, and the file, if the file is a log file, say for a server or something like that, what you can do is have a window that is executing the tail -F command in a script with a file, and having it repeatedly show the last 10 lines of this file. And so as this log file gets updated by the server, it will actually keep scrolling and add additional lines to the bottom of the screen and continuously show the last 10 lines of the file. And so this becomes a very useful thing so that someone managing a bunch of system programs or programs that are running continuously on a server to actually quickly look over at a window and see what the current status of the system is, because these logs are constantly being displayed with the tail command. Process management, you can see the various commands here, display the top running processes. PS is a way that you can actually see the actively running processes. This is important so that you can actually monitor what processes are running currently, and even we can see here the kill command actually kill a specific process. This is, you find that you actually use this command a lot. There's all kinds of different command options that with the PS command to filter or show specific types of process, filter out what processors you actually want to look at. And so again, that is a very useful command. In the kill, if you have a hung process that you can actually kill a process that's hung. And believe it or not, you do use that from time to time. There actually is a kill -F option, which is nicknamed the kill with extreme prejudice. Basically, there are certain processes that you're not supposed to be allowed to kill, particularly commands that actually have child processes that are running. And if you use the kill -F, it basically will kill it no matter what. That's why it's called kill with extreme prejudice. It will kill anything any process indiscriminately. So of course, with that indiscriminateness, you have to be very careful on how you use that particular command. You can actually run processes in the background and foreground. File permissions. The change mode command is a very useful command. This is to change the file permissions for access to a file. In particular, if you're the owner or if you're a super user, you're allowed to change the permissions. And the change mode command uses an octal word to describe what you're trying to do, what setting you want to set for this particular file. So here's the file, and basically we were looking at the octal representation. The fourth bit, the power to the fourth value being set, says that you have read mode access to the file. The power 2 bit says you have write permission to the file, and the 1 bit says execute. So how many of you are familiar with octal? Or how, I guess maybe I'll phrase it, how many of you are unfamiliar with octal? So
I haven't used it.
yeah, so as a programmer, you should get used to octal and hex, because you will run into instances where knowing the octal or hexadecimal base number system is useful. And in fact, in networking, you use hex all the time. So if you're doing networking software, you're going to be forced to be using hex a lot. So you should be able to read an octal or hex number fairly fluently, especially, again, like I said, if you're doing networking, but just in general, it's a good skill to learn. So an example is here, change mode 777 and then a file name. 7, if you looked at it in binary, is 111. So in octal, 111 or binary is 7. So it's basically got the read bit set, the write bit set, and the execute bit set. And so that's 7. So that means read, write, and execute. And then it says for all. So what this is the first 7 represent the owner of the file has the ability to read, write, and execute. The second 7 represents the group. So as a user on a system in Linux, you have a user account, but each user account is assigned to one or more groups. And so this says that people in one of my groups also have read, write, and execute permission. And then 7 is for all, or world permission is another terminology that you will hear. And that is everybody else that's not either the owner of the file or part of the group. They will get permission of the last digit here, the last octal digit. So this looks like a regular decimal number, but you will never see an 8 or a 9 because it's octal. So it goes, the digits will go from 0 to 7 in octal. Here we can see another variant, which is 755. And so 5 in octal is 101. Again, when I see 5, I see floating in my head right in front of me 101. And so this will allow for the read, not the write, because that's 0, and the execute permission. So 101 will allow read and execute for both the group and the world or everyone option. And then the owner is allowed to do read, write, and execute all the permissions. So that's an important command and concept to understand. So I definitely will make sure that you understand that and recognize that. grep is a powerful tool for searching through files. It's used very heavily in scripting, but also you use it very heavily in just regular command line use. So grep actually search for patterns in files. So it's searching for the contents of something in your files. And the pattern is actually what is called a regular expression. And so it is a method for specifying pretty advanced search capabilities. And normally I do an example on the board. Let's see. Let me create a whiteboard. There is a whiteboard sharing option. Escaping me right now. Anyway, I'm sorry. When I was teaching online, I was able to flip back and forth to the whiteboard, and I can't seem to find it right now. But for instance, so you can see here in the example they show, common used way to do it is a command with this pipe character, which says, execute this command and feed the output of the command to this next command in the list, which is the grep command. And you have a pattern here, which is the thing that the regular expression that says what we're searching for. So one common way that this can be used, or one way, is you could actually have the ls command. You can say ls minus al as your command here. Use this character here, which is the pipe character, which says feed the output into here, and then you do a grep, and then the up arrow caret, the caret character, and then a D. And it seems like rather complicated, but what it does is the up arrow, the caret character, the character above the 6 on your keyboard, the caret character, says that you're supposed to find the first, you're supposed to find the occurrence of that at the beginning of what we're searching, beginning of a line in the file that we're searching, in the command we're searching. So the ls minus al will list a series of lines, each with a file on them. When I say look at the first character and then a D, it's actually saying in that listing, look on the very first character of that line for the letter D, and I want you to show me only those lines that the first character is D. Well, if you look at an ls minus al output, the first character is generally a dash, a minus sign, but in the case of a directory, it will be D. So when you say ls minus L and pipe it to grep, and then you say the caret D, you're actually telling the command line processor to show me only the directories. So that is one way that grep can be used, but there are many, many ways that you can do the command line. Use the command line in very powerful ways in both scripts and in just executing commands. So was that understandable, that grep example, or was that somewhat confusing? Did I lose anyone on that description? Sorry, the wrong one. Did I lose anyone in that description? Okay. All right. So moving on, I'll skip some of this. Who am I shows you the name of who you logged in as. The reason, it seems like a kind of a strange command, but the reason why that's useful is that you can actually substitute user, which means change who you are with a command. There's an su command that substitutes user. And in particular, the case where you would actually do a substitute user or sudo, which is a substitute user in a little bit more controlled fashion, is so that you can actually go into being the super user. So you can do special commands that normal users can't use. And even if you have privilege to use super user capability, you generally don't use that. And I think I explained this before, unless you know that there's something specific that you need to do that has those permissions. And so who am I will actually tell you who you are, and in particular, do I have super user privileges right now when I'm typing? Do I have to be really careful? Or did I actually log out of super user mode into my normal user mode, and I can sigh a relief and not be quite so careful? So anyway, that was my 5-minute warning. Are there any questions about anything I've covered here or about the class in general? Again, we will be having a quiz on chapter 1 on Wednesday, and my goal is, and I think I should be able to be in class on Wednesday.
Professor Lim, didn't you say earlier that you had it scheduled for Friday, or did you decide to switch it to Wednesday?
Oh, you're right. It's Friday. It's my software engineering class this Wednesday.
Okay, thank you.
Thank you, Gabe. Thank you for the correction. Yes, those of you in my software engineering 1 class, you have a quiz on Wednesday, and the operating system quiz is on Friday. So that hopefully that will help those of you that are in both my classes, so that you don't have to try to study for 2 of my quizzes on for the same day. All right. So anyway, I plan to post a video on YouTube of the lecture recording, and I will also post my administrative slides, and then again, my lecture slides are also available in the modules section of Canvas. So anyway, stay if you have something you'd like to ask me in person. Otherwise, you're free to leave.
Thank you.
All right, thank you.
Have a good day, Mr. Lim. Hope your foot feels better.
Thank you. I'm praying it does too.